For number 35, we do have to find the error between these curves, and now we do have to use a graphing calculator because it would be very difficult to draw this cubic function. So whenever you see this symbol over here, it usually means that you're okay to use technology to solve the problem, at least partially. So that's what we're gonna do. So I've put in these curves in my graphing calculator, and we can actually see that that there's 3 points where they intersect. The first one is over here, the lower one, right? Minus 1.115. And then this point over here, 1.254. So in this first integral, the blue curve, which is the cubic, is the upper function. But then this may be a little hard to see in the graph, but then they do intersect at a different point. So they do have this other interval where the square function is the upper curve. And then it goes, let's see, they intersect somewhere here. Let's try to find it. Yep, this point. So at 2.861. So let us just set this up in different parts, right? We'll begin with the first part, which is the second point. It's not the -1 because that is the point of inflection, but rather, sorry, not inflection, that is where it changes direction, but rather the second point over here, which is minus 1.15, and then all the way to 1.254. And the cubic function is the upper curve. So the first integral goes minus 1.115 to 1.254, and we do have the cubic function as the upper function, so that is x cubed minus 3x plus 4, and then minus the lower function. So minus 3x squared minus 2x, and all of this times dx. And now let's set up the other integral, which the lower boundary is 1.254, and let's just go back and double check our upper boundary. Let's see where it is. Yep, 2.861. That is 2.861, and now we have the square function as a upper boundary. So this is 3x squared minus 2x, and then minus x cubed minus 3x plus 4, all of this times dx. So let's just clean up these integrals a little bit, and then we'll evaluate them. So then it is the integral from negative 1.115 to 1.254, and that is x cubed minus 3x squared, right, over here. So minus 3x squared, and then we have minus 3x over here, minus 2x, so that is minus 3x plus 2x, so minus x, and then plus 4, and all of this times dx, and then plus the integral from 1.254 to 2.861 of, let's see, that is minus x cubed plus 3x squared, and then minus 2x minus 3x, so plus x, and then minus 4 times dx. So let's just double check our math, see if everything is okay. X cubed minus 3x squared, yep, and this other one as well. Yeah, all good. So all we have to do now is just integrate using the reverse power rule, and then apply our boundaries. So this is x to the power of 4 over 4 minus 3x cubed over 3 minus x squared over 2 plus 4x from negative 1.115 to 1.254, and then plus minus x to the power 4 over 4 plus 3x cubed over 3 plus x squared over 2 minus 4x from 1.254 all the way to 2.861. Let's see if that is right. X to the power 4. Yep, all correct. I like to always double check my work in these long problems, just because if we make a mistake, we have to start all over again, and that's quite annoying. So for this one, because we are allowed to use technology as part of it, instead of just manually computing the upper and lower for both of them, because it will be a very long calculation, I'll just input it into my calculator, and this is approximately 8.38. So that is the area between these two curves, and it is split up into two different parts.